Last time we introduced a standard form of an equation for a circle. In this lesson, we're going to take a look at non-standard equations of circles in order to see how to extract graphical information from those. So let's start by recalling the standard form of an equation of a circle. It looks like this: x minus h squared plus y minus k squared equals r squared. And here, by the way, remember, at h and k are the coordinates, the x and y coordinates of the center of the circle, and r is the radius. It can happen that an equation for a circle might appear in a non-standard form, one that doesn't look like the equation form we have here on the screen right now. So here's an example: x squared plus y squared plus 6x minus 4y minus 3 equals 0. You can see this doesn't look quite like the equation form above. For one thing, you don't have x minus something squared and y minus something squared. X is being squared and y is being squared all on its own, or all on their own, for example. But if you look at this equation, there are some clues to tell us that it is an equation for a circle, despite not appearing in that standard circular equation form. One thing is that we have both an x squared and a y squared term. And both of those terms have a coefficient of 1. If you see an equation that has these two features, you can be confident that its graphical representation is that of a circle, even if you can't right away get all the information about the circle that you might want to get from it. Let's see how we can convert a non-standard equation, like the one we just looked at, to the standard circular equation form. So our goal here will be to find the center and radius of this circle, the one represented by this fairly complicated looking equation here. Again, we know it's a circle, so the circle has a center and it has a radius. We can't right away figure out what they are, though. But if we can rewrite our equation to put it in our standard circular form, then we will know exactly where to look in that equation to find the center and the radius. This is going to require some algebra work. And the main method we're going to use here is the algebraic method called completing the square. You may have seen this before as a technique for solving quadratic equations or something like that. We're going to use it here to rewrite our equation and put it into standard circular form. To do this, let's recall how the method of completing the square works. What it does for us is to take a perfect square trinomial and allow us to write it as the square of a binomial, or rather, I should say, completing the square makes the perfect square trinomial, and then we can rewrite that by factoring into a square of a binomial. So here's how to do this. Let's say we have the expression x squared plus 8x. We're going to complete the square on this and then factor the result into the square of a binomial. The first step is to take the coefficient of x and to divide it by 2. So we have 8x in our expression. We're going to take the 8 and divide it by 2. That gives us 4. Now we'll take the 4 that we just got and square it. 4 squared is 16. We're going to add that number, 16, to the binomial we started with. So we're adding something new into here. It changes the value of the expression, but that's okay here. We're going to take x squared plus 8x and add 16 to it. That is now a perfect square trinomial, and it can be factored into the square of a binomial. In this case, it'll be x plus 4 squared. A clue that we need to use 4 here inside what's being squared is that is what we squared earlier to get the number that we added. We squared 4 to get 16. And that means when we factor, we're going to have x plus 4. So let's get back to our circle example. Here's the equation once more for the circle whose center and radius we want to find. To do this, and again, our goal is to put this into our standard circular equation form, I'm going to start by grouping together all the x terms and the y terms on the left, and I'm going to move the constant term to the other side of the equation. So when the equation is currently written, we have minus 3 at the end of the left side. I'm going to add 3 to both sides of the equation. So when we do all that grouping and manipulating of the equation, we get this: x squared plus 6x plus y squared minus 4y equals 3. Now notice we have 2 expressions here, one in each set of parentheses, that sort of have the structure required for completing the square. We're going to do this twice. We're going to complete the square for x squared plus 6x, and we're going to complete the square for y squared minus 4y. So for x squared plus 6x, we're going to add 9. Remember, you take 6, divide it by 3, and square the result. That gives us 9. So we're going to add 9. In y squared minus 4y, we're going to add 4. Take negative 4, divide it by 2. That gives us negative 2, and square the result to get positive 4. So we add 4. Now on the right side, we have 3. But notice here, we added some stuff to the left side of our equation. We added 9 and we added 4. If we're working in an equation, if we add stuff to one side, we need to make sure to add it to the other side as well. So we're going to add 9 and 4 on the right side as well. That ensures that our equation is equivalent after we do all this addition. Now on the left, we can factor. X squared plus 6x plus 9 is a perfect square trinomial. It factors into x plus 3 squared. Y squared minus 4y plus 4 is also a perfect square trinomial. It factors into y minus 2 squared. Remember, it was negative 2 that we squared to get the 4 that we added. And on the right side, if we add up 3 and 9 and 4, we get 16. Now our equation is in our standard circular form. And this makes it easy to identify the center and radius of the circle. The center is going to be the point negative 3, 2. Remember, the coordinates of the center are always what is getting subtracted from x and y in the equation. So where we have x plus 3, we need to think of that as x minus negative 3, and 2 is being subtracted from y, so 2 is the y coordinate of our equation. The radius is 4. Remember, in the equation, in the standard circular form, r squared, the radius squared, appears by itself on one side of the equation. We take its positive square root in order to get the radius of the circle. So that's the radius of our circle.